Hi friends, after looking into a circuit which converts an alternating current or a bidirectional current into a unidirectional, that is, which was flowing in both the directions, converted into flowing only in one direction. Now it is time to see how to convert this into a constant voltage. So we have input as only positive cycles, and we want output to be almost constant. So how can this be done? Yes, it can be done through a filter, and that is a low pass filter. So this, if you just look at this waveform, then we can see that all the time the output voltage is either 0 or above 0. Then if you just try to find average of the output voltage, then the average output is always greater than 0, whereas average of this is always equal to 0 because positive negative cycles cancel each other, whereas there is nothing negative to cancel it. Therefore, average is always greater than 0. And if we could get that average out, then yes, it is possible. So when you say average, average means it's a one which doesn't change with time, and it's what we are interested in. And if we want that to come out, then we need a low pass filter. A low pass filter, as we discussed earlier, is a series resistor and a shunt capacitor. And these R and C values are selected such that the cutoff frequency is less than our frequency of AC. Whatever alternating frequency we have, that frequency less than, we need a cutoff frequency. That means in India, Europe, some parts of Europe, it is 50 hertz, some other parts, it is 60 hertz. So, whatever it is, if you find a filter whose cutoff frequency is well below 50 hertz, then definitely none of these are available at the output. Only average will be available at the output, and this can be used for our purpose. Now, how to get this? Now, how did we get this? We got this using a diode in series, and then a resistor here. This resistor was a load resistor, so we want a voltage across this to be constant. Therefore, this has to be taken out. So we need this to put in. So we need a diode here, and then we can have this resistor and this capacitor. We are talking about this circuit, and then we can connect our load resistor here, and across which we are interested in getting a constant output. So this is our low pass circuit we are talking of. And if this resistance, if we get from the diode, that means where the diode is, the work of resistor is only when we have variation here. The work of resistance is only when we have variation here. That means only during positive cycles. And during positive cycles, diode is conducting. And if diode is conducting, this diode is not an ideal one. Therefore, it has got some resistance across it. So, if the forward resistance of the diode, if it can be made use of in this place, then our overall circuit would look like this. So we have input AC here, we have a diode here, we have a capacitor here, and this output voltage is almost DC. What do you say? This is going to be DC? Yes, let us check up what would happen. So when we apply positive cycle, when we apply positive cycle, in the first part of the positive cycle, what would happen is the diode gets forward biased because the voltage here is we started with collector voltage to be 0. So this point voltage is 0, this point voltage is increasing, therefore diode is in forward bias condition and hence current will be flowing, and this current will flow through the capacitor, charging the capacitor, therefore the voltage across capacitor keeps charging, and if the resistance of this is sufficient to produce enough current to charge the capacitor with the speed with which the input is changing or even faster than that, then definitely we can see the output having a similar rise as input. So as you just look at it, when the input is changing, output also changes. When we reach the peak, yes, it also reaches the peak. After the peak is reached, the voltage here gets less than the peak, whereas here the voltage is gone up to peak. So let me call it Vp. This is our Vp. So this voltage has gone up to Vp, and this voltage is now less than Vp. This is Vp, this is less than Vp. That means the diode is in reverse bias. Therefore, diode will not allow current to flow in the reverse direction, and there is no chance for this capacitor to get discharged. And hence, the voltage across capacitor is going to remain constant. So, what would have happened if capacitor was not there? Then the output would have gone low. Then again, in the second cycle would have continued this way, whereas because of this capacitor the output remains constant. So that's a concept of filter. It's going to remain constant, that is under ideal conditions, but when you look at practical conditions, then the diode, when reverse biased, we say it doesn't conduct, but that is ideal case. In practical case, yes, because of some minority carriers available in the two sides, some negative reverse current will be flowing, and that reverse current is going to discharge this capacitor. So there is discharge possible. Other reason for discharge is the media between the two plates is not a perfect dielectric, hence there is leakage here, and because of which this voltage keeps reducing. And one more reason is the current which is flowing into the load resistance will discharge this capacitor. Now the thing is the amount of charge it has stored, if it is very high compared to the discharge possible because of this reverse current or discharge possible because of this leaky dielectric, or discharge possible because of the load current, then yes, there will be almost constant voltage across this, though it is varying slowly. So in this half cycle, instead of remaining constant, it varies slowly, and in the next cycle, yes, this is get compensated, and again the capacitor gets charged. Whatever charge it has lost during this half cycle gets added to it in the small part of positive cycle, and then again it continues to leak and then gets charged, then slowly discharged. Only thing is, during forward bias, very low resistance, therefore fast charging. During reverse bias, very large resistance, so very small current in the reverse direction, so very slow discharge. The dielectric is leaky, but still better dielectric, therefore the leakage is very slow, and the current used to drive the load is small compared to the capacity of the capacitor here. Therefore, the current at the load also drives this charge very slowly, and because of which the charging process is very fast, therefore it follows our input, whereas discharge path is very slow, so it slowly reduces and then in the next cycle again gets. So instead of getting this type of changes, you get this type of changes. Yeah, compared to the old version, that is AC, definitely this is better compared to unidirectional output of the rectifier. This is better, but still you find some variations, and these variations also need to be stopped, and that's what is to be taken care by something called a regulator, which we are going to see in our future section. But before getting into regulator, there is another option, that if we can take the missing negative cycle, if we take the missing negative cycle and convert that into positive cycle, then our situation would be better, because the discharge path is almost half cycle, and if you can add the negative cycle as a positive cycle here somehow, then the discharge path or the discharge time will be very small. Therefore, the amount of charge discharge will be very small, and hence this looks even better than that. So, what are we doing? Here is we are rectifying, and we have been using only half of the cycle. So, this is called a half wave rectifier, and we are going to have one more rectifier called full wave rectifier, which converts both the cycles into positive, and thereby these undulations can be further minimized. And that's what we are going to see in our next session. Till then, take care. Bye.